Hi, I'm your host, Praveen Ravisankar, and this is the Data Standard Audio Experience. We have a very exciting guest today. On our podcast, we have Sinan Ozdemir, Director of Data Science at Directly and author. Today, we're speaking about the use of natural language processing in industry, and we're going to touch on feature engineering. Welcome to the show.
Thanks for having me, Praveen. It's great to be here.
Sweet. Thanks for coming on the show today. Go ahead and introduce yourself.
Of course, my name is Sinan Ozdemir. As you mentioned, I am an author, entrepreneur, and currently the director of data science at a company called Directly in San Francisco, which is also where I live. As I mentioned, I am an author. I'm currently writing my fifth book on feature engineering. Well, my fifth book overall. This is one of my books on feature engineering, where I am focusing on delivering content to help data scientists at any level understand how to manipulate data and engineer features to make machine learning pipelines more predictive, more fair, and also more efficient. So it's a book that really focuses on how do you change up the way you're interpreting your data as opposed to coiling away hyperparameter tuning all of your machine learning models. So it's really showing the different side of the coin where the data comes into the model and you expect the model to do everything, but this book focuses on, can't you manipulate the data in such a way that actually makes the model more predictive? So that's really the narrative throughout the entire text.
Okay, sweet. I mean, I think it's safe to say that you're more than qualified for this podcast and incredibly passionate about this topic.
Yes, definitely.
Yeah. And so first I want to touch on your work that you're doing currently, like in office, right? I understand that Directly focuses mostly on reimagining customer service and integrating artificial intelligence and chatbots to many of these companies. More than like the direct implementation, I wanted to ask about why you chose to work at this company and what makes the data that you work with so interesting to you.
Absolutely. So I actually came into Directly through an acquisition. So previously, before Directly, I had started a company called Highly.ai, where we focused on the automatic building of chatbots and conversational AI through parallelized crowdsourced data, and Directly acquire that company to bring the technology into their platform, into their product line. So what I'm doing it Directly is really moving forward with my work. How do we put a crowd of people, a global crowd of people first, and make an AI crowd-driven platform that can auto-generate conversational AIs, chatbots, and also use that crowd to identify weak points in the bot and self-heal those as well. On the other side of the coin, Directly is also using that crowd to pick up the slack where the bot can't do the work, because anyone who says their chatbot can perform 100% of conversations, unfortunately, is lying. So we also use that crowd to say, okay, well, when the bot messes up, when the bot doesn't understand what you're talking about, our crowd, send it to the humans to finish the job. And then our loop basically is take the conversation that the human had, feed it back into the bot, and make the bot even better. So we're constantly in this loop of update the bot, put the bot out there, have the humans pick up the slack, rinse and repeat.
Oh, that's really cool. And congratulations, first of all, for getting your company acquired.
I appreciate it.
Yeah. Sweet. And kind of going on the topic of chatbots, I understand that you're a specialist in natural language processing, or NLP. And how does this affect your work? And how do you see this kind of transforming the future of this industry or any other like industries?
Sure. So natural language processing, NLP, is a really broad term, right? It's a branch of artificial intelligence that, simply put, is just dealing with the way people use language to communicate with each other and with their machines and with the world around them. Very vague sentence, but that's really what natural language processing is. And a lot of people would say, well, NLP is just text data, text vectorization, word to vec, bag of words, all those kind of simple things. But really, voice is language as well. And we have to talk about all of the different ways that people use language to, again, communicate or describe or explain something. So when I think of NLP, I think of a huge breadth of work ranging from the classic, as I mentioned, word to vec, bag of words, speech to text, to state-of-the-art GPT, BERT, Google's new Lambda announcement the other month. So there's always been a need to process language data. Most data created by enterprise companies is unstructured, whether that's audio, video, text, audio logs, all those things. And so NLP was always there to say, well, how do we take this raw data that's just sitting in our database and convert it into something useful? And out of that, we get speech to text. Out of that, we get our Alexas and our Google Homes. And out of that, we get all these new technologies where voice and texting and conversation is the norm. You don't have to necessarily click on these buttons to tell the computer what you want. You can just tell it what you want to some degree.
Yeah, that sounds, I mean, it's kind of interesting to think about how NLP is so integrated, or I mean, like the topic of NLP is so integrated within a lot of these companies. How have you directly dealt with it, and what has been your favorite application of it so far?
Absolutely. So at its core, one of the simplest natural language processing tasks is to do some kind of a regression or classification task where raw text is your input. Now, that's when the data scientist has the freedom to get creative with, well, what is that classification? What is that regression? How do I structure this machine learning task into a real world problem? So directly, for example, we have about at least a dozen different machine learning models all constantly out there and listening to data, updating themselves, and making sure that the predictive power is always getting monitored. But one of them, as a very simple example, is something we call predictive routing, which is at its core a question will come into our system or a conversation will come into our system. And within milliseconds, we have to make a decision of what should we do with this question? Should we try to automate it? Should we send it back to our client because it's going to lead to some PII data coming in that they don't want? Should we send it to our crowd of human experts to take up because we know our bot's not going to be able to handle this really well? And we have to make that decision in a split second because A, we are trying to deliver the best customer experience to the end user, right? This is all in service of the end user. They want the best experience. So if we send them to the bot every time and our bot has a 70% chance of getting it right, 70% of people are going to be pretty happy, but the other 30% are going to be so mad that they have to go through a bot first. So can we redirect that 30% to not even hit the bot at all? So that's a very, at a high level, it's a really simple example. Text comes in, you got three options: classification. But at such a scale, when you're dealing with tens of thousands of questions a day and tens of thousands of experts and humans all over the world constantly answering questions, how do you design the system that not only is it accurate to a degree where we're optimizing customer success, but how do you keep up to date with what the crowd can and cannot do, and take in other variables like what time of day is it? How many people are online right now to answer this question? How long is this question going to take to resolve on average? And all of those factors become a deciding feature, back to feature engineering, a feature for our machine learning model. So it's not just text. NLP is not just text. NLP is how do we incorporate raw text into machine learning pipelines, even when you have structured features already at your disposal.
No, that makes a lot of sense. I guess this is more of like a personal question for me. And I've been dealing with some text data sets, right, recently. Like this is from a college student's perspective. And I wanted to know, like, as someone who's getting into data science, how would you go about tackling a certain text data set? Right? What's the best way to break it down when it comes to sentence structure, when it comes to highlighting keywords and like making your first chatbot? So what are just some like big ideas or tips that you would give someone starting out and is trying to start, working within NLP?
Yeah, NLP is the reason I am a self-described specialist in NLP is because when I was in college, I started working with text data and I kind of had this epiphany where I said, this is how people talk. This is the fun stuff for me, right? It's one thing to be handed a CSV of structured data and say, here's your response and here are your features, make me a model. It's like, all right, fine. But how did we get to this structured data point, to this data set? How did we get here? And And NLP, along with image technologists, computer vision specialists, they have this urge to say, well, let's take the raw stuff and figure out what can we do with it to make it more predictive. So for someone who thinks text data is so interesting, anyone out there who's trying to get into NLP, really the basics of NLP come down to how do you tokenize your text, which is basically breaking the text up into segments, whether that's words, phrases, characters, and that's all in service of performing text vectorization. So vectorization, as as the name suggests, is turning text into vectors. So how do you take variable length text, 5 words, 5 sentences, 5 paragraphs, into a fixed length vector of size X, 512, 768, 1024 length vectors, whatever that may be. How do you turn variable length text into a fixed length vector? That's text vectorization. And at its simplest, algorithms like bag of words, count vectorizers, TF-IDF vectorizers, these are all available in scikit-learn, and anyone who's in the space will recognize the name scikit-learn. And if you don't, definitely go look up scikit-learn. These are all implemented in there. And as you move towards state-of-the-art deep learning-based methods, you're getting into something called transformer technology. Transformers were something invented in 2017 in a paper called Attention is All You Need. And since then, if you've ever heard the term BERT or GPT, both architecture 5 and Google's newest Lambda architecture, all of that is based on the transformer architecture from 2017. So there's been this new wave in the last 5 years of NLP, state-of-the-art NLP technology, which is why I'm writing about it in my book, and also I do lessons for Pearson and O'Reilly on these kinds of deep learning based technologies, because they are the true state of the art. So it's a big field. And for people getting out there, people just kind of getting their feet wet, start with the basics of text vectorization, count vectorizer, TF-IDF vectorizer, because at the end of the day, you're performing a machine learning task, classification, regression, named entity recognition, some kind of a task that you can measure. So in that case, it's not going to be so different than taking in a structured CSV. But it's all about how you convert that raw variable length text into fixed length sequence vectors. And that's the key.
No, that makes a lot of sense. And I wanted you to switch hats to put on your author hat. And I understand that you've had a lot of experience in both academia and the industry. So you have a lot to say, I'm guessing. I wanted you to touch on your book and what made you so passionate about feature engineering and why you wrote it.
I love this question because to your point, I get to speak about, I used to be a teacher. I used to be a full-time educator, and I was a teacher I taught online high school for a while. I taught in prison systems in Maryland for a while. I recently taught in boot camps like General Assembly. And I also was a lecturer at Johns Hopkins in Baltimore, Maryland. So I've had this pretty wide array of teaching experience. And when I decided I wanted to get into entrepreneurship and start my own company, which was Highly that I mentioned earlier, I still wanted to not just keep a foot in the door of education, but really I'm so passionate about education because, well, among other things, it unlocks people's potentials to grow and move forward. And at the same time, I always believe that teaching is the best way to learn. So when I'm hiring someone, for example, one of the interview questions I always give them is, teach me something, and I'll ask them this in advance, so they're not thrown off by it. But come in with a 5-minute presentation on something, and I would like you to teach me something. That's what I want you to do for 5 minutes, because I'm looking for that ability for someone to explain what's in their head to me, and that skill of teaching is so crucial. So I wanted to keep that muscle activated, so to speak, right? I wanted to make sure I always had that ability to take what's in here and get it out there as efficiently as possible. So the books became a way for me to kind of asynchronously teach. So if I had an idea about principles of data science, my first book, or machine learning for cybersecurity, which is one of my other books, and now feature engineering, when I have these ideas that I want to talk about, I feel like writing a book is probably the best way for me to get it all out there and then put it in a way that I think people can pick up over and over again.
No, yeah, that makes a lot of sense. And kind of delving into your book that you're currently writing, right? What are some common misconceptions that you see within feature engineering? And do you have any advice for people who are, currently building models and don't want to like overly tune their models or vice versa?
Yeah, I think one of the biggest misconceptions that I've seen personally when it comes to feature engineering is most people will say feature engineering is nothing more than just removing the features that aren't working or adding features to add signal. And usually the guiding principle that people will have is, well, more features should be better because I'm adding more signal for my model to figure out what to do with. The problem with that guiding principle is the more you add features, the more columns basically you add to your data set, the more you're trusting your machine learning model to, quote, figure it out. And machine learning models aren't always the best at sifting through noise and sifting through unhelpful signals. Not all models have the ability to ignore features if they prove to be not so useful. And not all models have the ability to say, oh, you've given me 10,000 features, thanks. Like, what am I going to do with all of those? Like, I don't know where to start. And so it takes longer to train. You'll see actually less predictive performance when you add features that aren't relevant. So it's got to be a give and take. Which features are going to be useful? Which features are adding too much noise? Which features have just enough signal to make the model perform at a rate that I'm comfortable with? On the flip side, there's not just adding and subtracting features, there's also transforming features. So you're talking about principal component analysis, singular value decomposition for dimension reduction, autoencoders, and generative adversarial networks for images. And it's about transforming data from one kind of data to another more useful kind of data. So feature engineering is such a huge topic that ranges from exploration and data analysis and what are the levels of data all the way to how in the world am I going to combine raw text, time series, and images all into one model to make it perform one task for me. How do you do that? That's feature engineering. That is the range of feature engineering that we cover in the book. And that's the range of feature engineering that people ought to be aware of, because when you focus so much on your models, you're a lot of the times you're spending hours trying to get that 1% bump in accuracy where you could have been tuning your data this whole time and probably gotten the same gains, if not more, while your model's actually performing faster because it has oftentimes more signal and less noise to sift through.
No, that makes a lot of sense. Well, thank you so much for sharing your 2 cents. And if you want to, do you have any books that you want to plug real quick that you've already written and or that are coming out?
Absolutely. And I can provide a link. There's actually, you can get my latest book for free on the Microsoft Azure website, The Principles of Data Science, second edition. It's a totally free book. I encourage people to download it. We'll make sure there's a link out for you.
Sweet. And we at the Data Standard are building a community of data enthusiasts and data thought leaders. Everyone is open for collaboration and wants to connect with each other. What can our community do for you?
Well, I am always happy to be part of this community. And I always love when people reach out to me with ideas or just want to chat about machine learning and NLP. One thing that I'm always looking for are talented individuals who are really looking to make their mark in this industry, and not just to say that, I'm looking for people who are always trying to one up other people, but I'm always interested in talking to young, bright minds who have their heads about what can we be doing to make this industry better. And better is vague, but better can mean more fair. Fairness is a big part of the book as well that I'm working on. How do we make machine learning more fair? How do we make machine learning more equitable? How do we make machine learning more powerful and useful to a wider variety of tasks? So I am always open for anyone to reach out to me, and then you can find me. Name your social media of choice. You can find me pretty easily.
Sweet. And thank you so much for being on our show today. We really, really appreciate your time. And for more information on the Data Standard, you can find us at www.datastandard.io. Thank you so much for joining, and I hope to hear from you guys soon.
Thanks.